We are working on 4BB, which is finding the slope from a table. Before we were working on finding the slope from a graph, now we're going to be focusing on a table and a little of as well as an equation. So keep that in mind. Our content objective is students will be able to compare the slope or unit rate in different situations. Language objective is students will be able to describe how to find the unit rate given a table, graph, or equation. Why am I learning this? Well, it's important for solving real-world problems, such as finding how quickly the amount of water in a reservoir is changing. So, going over some background knowledge as usual, we went ahead and already learned how to graph based off of an equation. What we did first is filled out a table. We had to scale a graph if it wasn't scaled for us to begin with. We made sure we labeled our X's and Y's or whatever it may be depending on the problem. We graphed it, made sure that the line extends through the graph. But now let's talk about how did we find the unit rate? Well, we found the difference in Y. So how did it change in terms of Y? In this case, it increased 3Y for every 1X. Again, 3Y for every 1X. And notice we used triangles to represent that. Unit rate triangle in this case was 3Y per 1X, which is the same thing as 3Y per X because 3 over 1 simplifies to 3. Our initial value, where did it initially start? It started at 0, when X was 0, Y was 2, or you could think of it as this ordered pair here, which is 0, 2. Either way, you would say at X equals 0, Y equals 2. So unit rate is slope and initial value is Y-intercept. So keep that in mind. So now this we also went over yesterday. The slope of the line is the vertical change over horizontal change. And I'm going to introduce another variation of that definition, something very similar, but just know that there's more than one definition for the slope. We also can describe it as rise over run. And so in this case, if I were to find the slope, I would find that the vertical change is going up 2, so that's a positive 2, and then the horizontal change is going over 1. So in other words, you could also think of it in terms of the change in Y over the change in X. So that's the new definition that I'm going to be introducing to you. So let's write that down real quick. The change in Y over the change in X. Okay, so all of these are different variations, but they mean the same thing. Vertical change over horizontal change is the same thing as change in Y over the change in X, and it's the same thing as rise over run. These are really closely linked because vertical refers to the up and down motion, which is your Y-axis, and that's why this is change in Y. And the horizontal change is the change that occurs from left to right, which is your x-axis, which is why we use the change in x. So keep that in mind so that you can see how they are similar, or the same technically. So here, just moving on, in this case, the slope would be reduced to just 2. But if you use a different point, or a different triangle, maybe this one, I notice a decline in 4, so that's my vertical change, or aka change in Y, over, let's see, what's our horizontal change? That'd be negative 2, or you could think of it in terms of change in X. So I'm going to have negative 4 over negative 2, which is 2. Notice these are equal. So no matter which 2 points you chose and whatever 2 triangles you made, you should still end up with the same slope. So what is the y-intercept of a line? Well, the y-intercept of a line is a point where the line crosses the y-axis. So with all the things removed, where does the red line intersect the y-axis? It occurs right there. And that ordered pair would be 0, negative 3. So I would say my y-intercept is 0, negative 3. Okay, so now let's just keep moving. This here is called your Y-intercept form. Let's just clear things up a little bit. Slope is the numerical value of your unit rate, okay, which is basically the number in front of your variable in this case. We were using this to represent the unit rate. Now we're going to use it to represent slope. And then this number here was once used to represent the initial value. Now it's also going to be used to represent the y-intercept of the line. Okay, so here we're going to go ahead and move on to our very first example. We're going to be asked to find the slope from tables. So right now, this is not what we're going to be doing right now. We're going to go ahead and go into what it would look like on a graph. This is not what you're supposed to be doing, but I kind of want to draw in some of your background knowledge to see how things are done. So if I were to have a graph, which you will not always have, but if I did, this is what would happen. You would plot all of your points. You would make sure all these ordered pairs form a line, because if it doesn't, it's not going to create an equation. It won't have an equation, okay? It only works if it's a linear. Well, then you're going to use your definition of a slope. Well, what's our definition of slope? There's two. The easiest and shortest one was the one we refer to as rise over run, but you know that I'm not a big fan of this one, and you know my reasons why. So I do prefer you to think of it as vertical change over horizontal change. So let's go ahead and figure this out. Here, if I chose these 2 points here, I would say my vertical change, well, first it's going to go up 1, 2, 3. Since it's going up, that's a positive 3. So I'm going to put that as my vertical change. Then it's going to go 1 to the right, so that's a positive 1 for my horizontal change. So in this case, my slope is positive 3 over positive 1, which would then just be reduced to 3. So I would say my slope is 3. Now, I know it doesn't say to find the y-intercept, but let's just go ahead and talk about what is the y-intercept in this case. Well, the y-intercept is basically where the line intersects with the y-axis, which occurs in this area right here. And I would say that ordered pair here is 0, 1. So I would say that the y-intercept is 0, 1. Now, on a graph, it's easy to see. However, on a table, what are you going to look for? You're going to look for when x equals 0. So once again, like I said, on a graph, it's super easy to find because you can see where the line intersects the y-axis, but on a table, not so much. So again, you're looking for, hey, when does x equal 0? So hopefully you wrote that down because that's going to come in handy. Trust me. Okay, so now let's actually do the work of what they asked us to do, which is to find the slope based off of a table by itself. Nothing else, no graph. So what am I supposed to do? Well, there's one important detail you need to understand. That slope is the change in y over the change in x. So you're probably thinking, oh my gosh, another definition for slope. How am I supposed to keep these all in check? Well, connect this to something that you already know. I told you that it's also vertical change over horizontal change. So if you're wondering, how are these linked together? Well, let me explain it to you. First of all, if you think about it, the y-axis runs up and down. That's what you call vertical change. And x-axis runs from left to right. That's what you would call a horizontal change. So notice these are linked together. So if you know one, you're going to know the other one. So here, what am I supposed to do? I need to figure out the change in y and place it over the change in x. So notice here, the coordinates are nicely labeled. The first column is x's and the second column is y's. So what I'm going to do first is find the change in y. So here I'm going to say the slope equals, what is the change in y? Well, it went from a 4 to a 10. First of all, it's getting bigger, so that's going to be plus. Well, how much bigger? From 4 to 10, I would have to add 6. So I'm going to go ahead and put that as my change in y, aka vertical change. You can use them interchangeably. Now I need to figure out what's the change in x. Well, how does 1 become 3? Well, definitely the number got bigger, so it's definitely addition. How does 1 become 3? I would have to add 2. So I'm going to go ahead and put plus 2. Now all you're going to do here is simplify. What is positive 6 divided by 2? This one I could actually divide evenly. It's going to equal 3. Okay, now I need to continue to check them. Why? Because if there comes a point where you check your ratios and they're not the same, what it means is it's not a straight line. So don't always assume you do it once and all of them are going to be 3. You have to check all of them. So now, moving on, I'm going to go ahead and do the next one. So here, I'm going to repeat the process. The slope is going to be the change in y. So how did a 10 become a negative 5? This one's a little bit harder to do. So what I'm going to do is show you a strategy. Okay. First, I start with the first number. Well, actually, first I should decide, did my number get larger or bigger? I'm going to say it got, I didn't mean larger or bigger. I mean smaller or larger. In this case, the number got smaller. So I'm going to be subtracting. Here, we're starting with a 10. And we're going all the way to a negative 5. Since these signs are different, I know I'm going to have to cross 0. So I'm just going to use a line to indicate that. First, in order to get from 10 to 0, I would have to subtract 10. And then in order to get from 0 to negative 5, I would have to subtract 5. So altogether, I would have to subtract 15. Cool. So now, that's how I got negative 15 here. So the next part is, what is the change in x? So here, looking for x, what's the change? I went from a 3 to negative 2. So did my number get bigger or smaller? Hopefully your answer is, hey, it got smaller. So I'm going to put a negative here. So this one, again, could be tricky for some. So I'm going to go ahead and write that down. It went from a 3 to a negative 2. Since there are different signs, I know for a fact that I had to cross 0 at one point. So first, how did 3 become 0? I'm going to have to subtract 3. And then from 0 to negative 2, I would have to subtract 2. So altogether, I would have to subtract 5. So here, I would say that I had to subtract 5. Well, now I'm going to simplify. I'm going to say a negative and a negative cancels each other out, which leaves me with 3. So far, so good. You should expect your rate, in this case, your slope, to be the same. If they're not the same, then it means it's not a straight line. So continuing on, I'm going to repeat the process for the next thing. So what's the change in y? Okay, how did negative 5 become negative 2? Think real hard before you give me a response. Did the number get bigger or smaller? Hopefully your answer was it got bigger. Okay, because it's a smaller negative. So here, I'm definitely going to be adding. But how did I get from negative 5 to negative 2? Some of you can do this in your head. Some of you can't. So again, I'm just going to show you real quick. How did I get from negative 5 to negative 2? So notice here, since they're the same sign, I'm not going to have to cross over 0. So I'm going to go straight from, how did negative 5 become negative 2? Well, first of all, it got bigger. And how much bigger did it get? It got bigger by 3. So here, my change in y, or aka vertical change, is a positive 3. And the next thing is the change in x. How did a negative 2 become a negative 1? Well, let's see. Negative 2 to a negative 1. Did we have to cross 0? Nope. So we're just going to make that jump. Since it did get larger, it's definitely adding. How much did we have to add? 1. So I'm going to say the change in x was a positive 1, which is going to leave me with 3, which is, again, a good sign. So now I'm just going to speed up the process. Hopefully you got the idea. So here, I'm going to start it again. Slope is, how did negative 2 become 1? I have to add 3. How did negative 1 become 0? I have to add 1, which would again give me 3. Now I have to check the last one, because here's the thing. If the last one doesn't work, then it's not a, there isn't a constant rate of change. Therefore, there would be no equation at all. So I'm going to just go ahead and check that. My slope is going to be, well, how did 1 become 7? I had to add 6. That's my change in y. And how did 0 become 2? Well, I have to add 2. So that's going to be my change in x. So here it does check through. There was a constant rate of change. So I'm going to say that the slope is 3. So some of you are going to get tempted. Why? Because you're going to want to stop and say, okay, I did it first. I know the answer is 3. But what if you, at the very end, did the work and it didn't equal 3? You know what that means? There isn't a slope because there isn't a constant rate of change. So please make sure you check all of them. Okay, on that note, let's just go ahead and move on to the next example. In our second example, we are asked to do two things. We're asked to find the slope as well as the y-intercept. So first things first, let's take care of slope. Slope, once more, is the change in y over the change in x. This is directly related to the vertical change over the horizontal change. So however you want to think of it, it really doesn't matter because it means the same thing. So first, the change in y. How is a -4 becoming a -6? Well, here it is getting smaller, so that's subtracting. How much is it getting smaller by? I would say 2. Well, then what is my change in x? It's going from 0 to 4. Well, first of all, it's getting larger. How much is getting larger by 4? So that's going to be +4. I am going to reduce this, and it would give me a -1/2. Now, what I'm going to do is, again, continue the pattern and look for the change in y. So how did a -6 become a -5? Well, the number got bigger, so I'm going to put plus, but how much? It only got bigger by 1. Okay, and then what is my change in x? Well, how did 4 become 2? Well, it got smaller, so that's subtraction, but how much? By 2. So notice here, +1 divided by a -2 is a -1/2. So far they're matching up, so that's good. I'm going to continue on. Here, my slope is going to be the change in y. So how did -5 become -1? It did get bigger by adding. So how much did we add? We added 4. And then what is my change in x? Well, it went from 2 to -6. It got smaller, so that's negative. But by how much? Here, just a quick reminder of how I would do this. Since we are moving from a 2 to a -6, these are different signs. So we're definitely crossing over 0. From 2 to 0, I would subtract 2. From 0 to -6, I would subtract 6. So altogether, I would be subtracting 8. So here, this would reduce by 4, leaving you with -1/2. So again, this is a good sign. Now, continuing on, the slope for the next one. What is the change in y? It went from -1 to -8. It did get smaller, so that's going to be a subtraction. How much are we subtracting by? Well, we're subtracting by 7. That's my change in y. But what's the change in x? It went from a -6 to an 8. It did get bigger. But by how much? Once more, let me show you. Since they're different signs, I went from a -6 all the way to an 8. Since these are different signs, we're crossing over 0. -6 to 0, we're adding 6. From 0 to 8, we're adding 8. So altogether, we are adding 14. This can be reduced by 7, so that's going to leave me with a -1/2. Again, so far so good. They're matching up. So far, we have a constant rate of change. But we're not done. We have to check the very last one. So here, what is my change in y? I went from a -8 to a -3. First of all, it is getting bigger, so that's going to be a positive. But how much? It's getting bigger by 5, so that's going to be my numerator for my change in y. Now, what about the change in x? It went from 8 to -2. So the number is getting smaller, so I'm going to put subtraction. So once more, I'm going to demonstrate that by saying, hey, I'm going from 8 to -2. I'm definitely going to have to cross 0 since they're different signs. From 8 to 0, I'm subtracting 8. And from 0 to -2, I am subtracting 2. So altogether, I am subtracting 10. This can be reduced, and it's going to leave me with -1/2. So notice here, we do have a constant rate of change. So I can confidently say that my slope is m equals a -1/2. So I can't stress enough with you, you need to make sure there is a constant rate of change, because if not, it's not going to form a line, therefore there is no slope. Okay, so now let's move on to the next one. Ooh, I almost forgot. We're not done, okay? We have to find the y-intercept, and hopefully you wrote this down from the previous slide that for y-intercept on a graph it's easy. I can visually see where the y-intercept is, but on a table not so much. You are looking for when x equals 0, and here you go. X equals 0, so my y-intercept in this case is going to be 0, comma, -4, because again, the y-intercept is a point on the graph. So there we have it. Our y-intercept is 0, comma, -4, and we did get the slope to be -1/2. So those should be the two answers for this problem. Okay, now I think we're finally done with number 2. Now for number 3, what I want you to do is go ahead and attempt this by yourself. Okay, so number 3 is slightly different, but hopefully you got the idea and you're going to do the same thing. So in order to find slope, I'm going to find the change in y over the change in x. Now the only thing different about this one is there's actual units. This represents candy bars and this represents cost. If it helps, you can label this x and you can label this y, so it's an easier transition for that. But I want to do the same exact thing. If I'm trying to find slope, I need to find the change in y. So how did $1.50 increase to $3? Well, I had to, first of all, it got bigger, so I'm adding. How much did I have to add? I had to add $1.50. Now, what about the change in x? We went from 2 candy bars to 4 candy bars. So obviously it got larger, so I'm adding. But how much did we add? We're adding 2. So this right here, because it's in terms of cost and candy bars, we're talking about money. You do want to keep it as a decimal, not as a fraction. So I'm going to say this is going to simplify to 75/100ths. Trust me. Now I'm going to repeat the process. I'm going to say, okay, equals, what is my change in y? It went from $3 to $3.75. So I'm adding 75 cents. That was easy. And then I went from 4 candy bars to 5 candy bars. So I added 1 candy bar. So that's going to reduce to 75 cents. I'm going to repeat this process again. Okay, so here the slope is, well, how did 375 go to 750? Think about money. How much would that be? Well, we would have to add $3.75. That's my change in y. Now what's the change in x? It went from 5 candy bars to 10 candy bars, so we're going to be adding 5 candy bars. Okay, I will do the math for you. This will reduce to 75 cents. Last but not least, we're going to go here. The change in y, it went from $7.50 to $4.50. Here, it is getting smaller, so that's subtraction. How much smaller is it getting? It's getting smaller by 3. And then here, you went from 10 candy bars to 6 candy bars. So how did that happen? Well, first of all, it is getting smaller, so that's subtraction. And how much are we subtracting? We're subtracting 4. So these signs cancel each other out, and hopefully you remember 3/4 is also 75 cents. So here, there's definitely a constant rate of change. So I can say that the slope, oh wait, not slope, unit rate, whoops. The unit rate is 75, what though? 75/100ths of something. If you remember, we should be setting up our ratios as y over x, and notice how nicely that can be pulled out from here. What is y? Y is the cost in dollars, okay? And what is x? X is the number of candy bars. I'm just going to put CB for short. So what is my unit rate? It's going to be 75 cents, okay, per candy bar. So notice I'm still going to use the ratio y over x to determine what my units are going to look like. Cost over candy bar. So in this case, dollar per candy bar. So what does that mean? It means that every single candy bar costs 75 cents. It actually means something. Now, real quick, it doesn't ask me, but if I were to ask you, what would the y-intercept be? What could you say? Well, if you remember, I did mention from previous slides, when you're looking for the, let me erase this so I can have some more space. When we're looking for your y-intercept, you're looking to find when x equals 0. So a reminder, y-intercept, you're looking for when x, did I say y equals 0? I meant x equals 0. So in this case, if x here stands for candy bars. If we had 0 candy bars, how much would it cost? Hopefully you said 0. Okay, so here my y-intercept would actually be 0, 0, because we would expect if we bought 0 candy bars, it would cost us $0. And that's how we would get our y-intercept here. Okay, so hopefully you were able to get the unit rate correctly. So now on that note, we're just going to move on to the next thing. For number 4, again, I want you to go ahead and pause the video and try this one on your own. Okay, so now let's try this one out. So first things first, we're going to find our change in y and compare it to the change in x. So I'm going to say the slope is, well, how did 102 become 136? Well, hopefully you start to realize when you're trying to find the change, you're technically subtracting. So here, how did 102 become 136? I have to subtract the two numbers, which is going to give me 34. So here the numbers did get bigger, so we're adding 34. That's my change in y. Now what about the change in x? It went from 3 hours to 4 hours, so it got bigger, so it's plus. How much are we adding? Just 1. So this is going to be 34. Now let's move on to the next one. How did 136 become 238? Well, here I'm going to say it's definitely getting bigger, so we're adding. So again, hopefully you recognize when we're trying to see how it's changing, we're technically finding the difference of the numbers. So we're going to 238 subtract 136, which is going to give me 102. Now, what is the change in x? It went from 4 to 7. It is getting bigger, but how much bigger is it getting? Just by 3. If you divide this, it would actually also equal 34, so things look good so far. Now for the last one, the change in y, how is 238 becoming 272? Well, it is getting larger, so I'm going to go ahead and put plus. How much are we adding? Well, let's do the math real quick to the side. 272 minus 238. This is going to be 34. So we're adding 34 for the change in y. Now what about the change in x? How is 7 becoming 8? That's easy. We're just adding 1. So this equals 34. So notice things look good because there is a constant rate of change of 34. But notice we shouldn't just say 34, right? There's some units involved. 34 what? Just a friendly reminder, if you set up your ratios as y over x, well, y represents miles and x represents hours. So my unit is going to be miles per hour. So I'm going to say my unit rate, since that's what they're asking for, is 34 miles per hour. And there you have it. Hopefully you got that one right. Now, moving on. For number 5, it says find the slope. So go ahead, pause the video, and try another one for yourself. Okay, so now we're back. Let's go ahead and go over these really quickly. I'm going to go ahead and do the same thing, change in y over the change in x. So first things first, how does 13 become negative 23? Well, first of all, it's getting smaller, so I'm going to subtract. Off to the side, let me do the work. I'm going from 13 to negative 23. Since they're different signs, I'm going to have to definitely cross over 0. From 13 to 0, I'm going to have to subtract 3, and then from 0 to negative 23, I'm going to have to subtract negative 23. So altogether, I'm subtracting negative 36. Now, change in x. How is negative 2 becoming 4? Well, it's getting larger, so I'm adding. How much are we adding? So again, real quick, this is the last time I'm going to show you. Since they're different signs, I'm going from a negative 2 to a 4. I'm definitely going to have to cross 0. Negative 2 to 0, I'm adding 2. From 0 to 4, I'm adding 4. So altogether, I am adding 6. So what's negative 36 divided by 6? That reduces to negative 6. Now, repeating this process, what is negative 23 to negative 5? Is it getting bigger or smaller? It's getting bigger. How much bigger? It's getting bigger by 18. Now, how about my change in x? How is 4 becoming 1? That's easy. It's getting smaller. And how much smaller? It's getting smaller by 3. So this also reduces to negative 6. So far, so good. I got to check my last one, though. What is my change in y? Here's my change in y. How did negative 5 become 19? First of all, it got larger. How much larger did it get? It got larger by 24. And what's my change in x? It went from 1 to negative 3. First of all, the number got smaller, so it's subtraction. How much would I have to subtract? I would have to subtract 4, and guess what? This also reduces to negative 6. So things look good. So here, I'm going to say the slope is negative 6. Hopefully that's the answer that you got. Okay. So now moving on to comparing slopes and comparing unit rates. So for number 6, it says, which situation has a larger slope? So I need to figure out the two slopes so that I can compare them. Well, let's see here. Use the same definition. We're going to do change in y over the change in x. So here, how did negative 6 become 3? Well, I would have to, first of all, it's getting bigger, so I'm adding. How much am I adding? I'm adding 9. So there, the slope is 9, positive 9 over. How is negative 2 becoming 1? I am adding how much? 3. So I'm going to say so far it's a 3. But I need to check all of them. So the next one I'm going to check is how did a 3 become a 21? I'm adding, since it's getting bigger, how much am I adding? Well, I'm adding 18. So that's going to be plus 18 over how is 1 becoming 7? I am adding 6. 18 divided by 6 is positive 3. So again, so far so good. Now last one. How is a 21 becoming a 42? I am adding 21. That's my change in y. And what is my change in x? I'm going from 7 to 14, so I'm adding 7. So here it is 3. So in this example, my slope is 3. Now I need to compare it to the graph. So hopefully, if you remember from yesterday, all you needed to do is pick 2 points. So in this case, I am going to override these points and pick these 2, just because I can. I need to determine the slope by finding our vertical change and compare it to our horizontal change, which is the same as the change in y over the change in x. So let me do that here. I'm going to count my vertical change. It's going up 1, 2, 3, 4. Since it's going up 4, I'm going to go ahead and put that as a positive 4. So far, I have a vertical change of positive 4 over, what's my horizontal change? I'm going 1 to the right, so that's a positive 1. So here, what's positive 4 divided by positive 1? I would say my slope is 4. So between these two options, which one has the greater rate of change? Well, I would definitely say the greater rate of change would be letter B. Okay, because here we have a slope of 4 comparison with the slope of 3 for option A. So option B definitely has a larger slope. Now what I want you to do is try number 7. Do the best that you can from what you've learned so far. Okay, so let's go over the answers. I'm going to go over these really quickly. So here, in order to figure out the slope, I must go ahead and find the change in y over the change in x. So if you don't know already, let's just go ahead and call this x, call that y. So what I'm going to do now is find the slope. How did 12 become 30? Well, I have to add 18. So far my slope is 18 over, how did 2 become 5? Well, I had to add 3. So here it's going to be 6, but I got to keep checking them. How did 30 become 24? I had to subtract 6. So it's going to be negative 6 over. How did 5 become 4? Had to subtract 1. Oh, look, this also equals 6. So far, so good. Now, I have to check the last one. How did 24 become 48? Well, I'm going to have to add 24 there. So my slope is plus 24 over, how did 4 become 8? Well, I have to add 4. Guess what? 24 divided by 4 is 6. So here I can say that the unit rate is 6, but 6 what? Again, notice it's going to be y over x. So it's going to be 6 miles per hour. So in this case, I'm going to say the unit rate is 6 miles per hour. But what about the equation here? If you remember, this term right here was the unit rate. But what does it mean? It means 31y per, whoops, I didn't write the right variable, 31y per 6x, which is the same thing as 31 over 6 y per x. This can be turned into a mixed number. Why would I want to do that? So that I can actually compare it more easily to 6 to see if it is bigger or smaller. So in my side work, I'm going to do 31 divided by 6. It's going to go in 5 times with a remainder of 1. So it's 5 and 1/6 y per x. So between these two, which one has a greater unit rate? Hopefully your answer is option B. Once again, takes the gold. Whoops, just kidding. It's not B, is it? They're asking for the greater rate of change, so this time it would actually be option A. Why? Because 6 is larger than 5. And there you have it. Okay, so now with everything, go ahead and try number 8. You should be able to definitely do number 8 on your own. Okay, so let's check your answers. Here, our unit rate is going to be, okay, this right here, which is 10y per 9x, which translates to 10 over 9y per x. But again, we might want to turn this into a mixed number. That way we can compare it with other values a little bit easier. So off of my side work, I'm going to divide 10 divided by 9. That goes in once with the remainder of 1, so it's 1 and 1/9. So this is 1 and 1/9 y per x. Now what about this graph? Again, all you need is 2 points. I'm going to pick the first 2 just because it's easier for me. I'm going to go ahead and see the vertical change. I always talk about how there's one above the line and one below the line. Just to practice, I'm going to go ahead and do the one below the line. It's going down 1, 2, 3, so that's going to be -3. My vertical change is -3 over. What's my horizontal change? It's going over 1, 2, 3 to the left. So that's also -3. The negatives cancel each other out. but so do the 3. So it's going to leave me with a slope of 1. So which one has a larger slope? Well, when I compare the 1 and 1/9 with the 1, I'm going to definitely say the one with the greater slope would have to be option A. And that's it. We have concluded the lesson. Hopefully you got an idea of how slope and unit rates are very similar, actually the same thing. But we also were able to compare them to see which one was greater. So like always, thank you so much for tuning in, and until next time, bye.